all of you. I think we'll go straight to the PPT. I'll be sharing it right now. I hope I have the permissions to share. I hope you can hear me.
Yes, sir. Yes.
Yes, sir.
Yes, sir.
Yes, sir.
So do tell me if you can see the...
Yes, sir. PPT is visible, sir.
Visible, no? Is it visible now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So the basic thing is, I do not know how much time we have. We have already lost about half an hour. And unfortunately, I got a meeting coming up soon. So I don't know how much time you have given to me, in fact, because it was 2 to 3. I was wondering what will happen now.
Sir, you can
Anyway,
take 1.5 hours. No, sir.
Okay. Let me try whatever I can. I hope to finish these slides soon. So one of the most important things which I would like to, especially in this kind of a pandemic situation, everybody seems to be talking about immune systems, immunity, and all those things. So I thought possibly this would be one of the better topics to discuss, especially since it's extremely relevant. And then, of course, how we can derive some algorithms, some kind of techniques from the immune system as such. Okay. So basically, it's all nature inspired. So before we go into the immune system, I'd like to show a few slides. One of the important things which I want to tell you is that please don't ask me these slides. So the most important thing for all the participants is that you take a pen and paper, you write it down, because that's a very important thing to write it down. Nowadays, nobody writes it down. No, everybody shares videos, everybody shares PPTs, and finally, you don't look at anything other than that closed world of a PPT or a video. But on the contrary, if you write some things down, then you may miss writing some things down. So then you go to the internet, you find out more things, and in the process you discover more than what I can expose you all in just about an hour or so. So please don't look at these videos, don't look at these, don't expect to have these slides. You please understand the whole thing. Everything is available on the net. Much more information is available. The only key point to be done is that you write down all the keywords and then search for the keywords, and then you'll learn much more than what I can deliver in this short period of time. So please keep your pen and paper handy and jot as much as you can as we go ahead. In the course of this, I'm not sure. I think today is possibly the first day of this course. Possibly, I'm not sure. So in any case, you'll be hearing more about mostly about machine learning. So we will try to avoid machine learning because there will be possibly intensive lectures on machine learning coming up soon. Others may possibly pitch in to do that from what it looks like. The point to be noted now is that when you consider machine learning, it's everything else about data, which means you have to have data. You have to have not just data, you have to have large sets of data, which they call as large data sets, which becomes a complete prerequisite for a machine learning algorithm. So modern day machine learning depends solely on data sets. If you don't have a data set, you learn nothing at all. So that becomes a very big problem in today's world of so-called AI, which is leaning mainly towards what are called as deep artificial neural networks. Do bear in mind that artificial neural networks existed way back possibly even in the 60s. But the problem was that we did not have that much of computing infrastructure. Since now we have lots and lots of computing infrastructure, they have put in more amount of layers in it and called it deep artificial neural networks, and then trained it on large data sets and then got some kind of results. But still, we are far away from the real goal. Many things are still missing, though there's a lot of hype. The basic problem is that they have not actually been implemented into real available commercial systems. There's still a long way to go. And the more important part which you must remember is that once you have a data set, you would make a neural network train a data set. Well, it trains very well. You might get some accuracies like 90, 95, 96, 98, and it keeps on increasing towards 100. But that is okay. The point is that it only knows about that data set. The moment you change the data set, more importantly, if you add more things into the data set, there's no guarantee whether this so-called machine learning algorithms, which bank on deep neural networks, will work in the same way or not. So that is creating a lot of problems. And then people are looking at different other ways of doing it. But somehow, most of the people who are around across the globe, they seem to be stuck at one thing, stuck at deep neural networks. Everybody wants to work on deep neural networks. And why is that so? Because there is data, large amounts of data already available, and they keep on churning out more information from the data. And they say that they have incrementally done better than the other. So this research, though it has to be carried out, but you also have to think from a different angle altogether. A different angle in the sense you have to think about a change in paradigm. Why only neural networks? Why can't there be other networks? So that's what we are trying to look at right now. So we are going away from this in some sense, trying to discover other ways of doing the same thing. Okay. So what are the other things that we need to look at? We need to look at nature, and nature has solved so many problems which, as a matter of fact, what you can do possibly cannot be done by the neural network. Unfortunately, because the neural network doesn't really copy the neurons in your brain. It is a different algorithm altogether. The brain works on a different algorithm. The neural network works on a different algorithm. Though they say there's some similarity, deep inside it is not so. So therefore, we have to again look back at nature, trying to find out how nature solves these kind of problems. Most of for those who are sitting here and for those who are students, do remember that when you go through the course, the teacher teaches you from a textbook, and he or she makes you believe that is the ultimate truth. That is not the ultimate truth. That may be the truth, no doubt, but it's not the ultimate. So do go beyond the textbook. Do go outside your room as such. Look at nature and then try to think out of the box. Nature has provided many solutions, many simple solutions to complex problems. I repeat, simple solutions to complex problems. So this, unfortunately, we are missing, and most of us, at least on this side of the world, we always think about what the Western world does, and then we imagine that is gospel truth, and we go on, going gaga about it. It's time we look differently across nature. In fact, we are in a tropical country. Nature has blessed us with almost everything. We have got snow. We have got large coastal belts. We have got the deserts. We have got everything which other countries don't have. Many landlocked countries in Africa, in other places too. They don't have a coastline. They don't have snow. They don't have many things. In fact, we have almost everything in our country. So I think it's time we looked at nature. We looked at how nature solves problems, and then try to extract the engineering within nature, and then bring up new solutions to new and simple solutions to complex problems. So this is my advice across the lecture. This is the main trend as what I want to hit on and make all of you do as such. Okay, let's have a quick look at what nature can provide. Here's what nature can provide. If you see all these snapshots, they've been taken from here and there. Of course, I've not been able to put up from where they've taken. They've been taken from the internet. So